Student handout 6% error. Absolute error. The absolute error is the difference between the approximated amount, or our estimate, or we can just write approximate there. Let's write approximate. And the exact or true value, like what it really is. It can be solved by finding the absolute value of the difference between the approximate value and the exact value. So the difference means we're subtracting and the absolute value of that. So let's think of some words that mean approximate, such as guessing, counting. Let's make that so you can read it, sorry. Observing, and measuring. Because we can make errors in our measurements, that is an approximate value. All right, the true or actual or the expected amount are our exact. Okay, now a science experiment calls for 150 milliliters of water, but Simon measures 147. What is the absolute error? So our approximate amount is 147 minus the actual, what we need. That gives us -3. We got to take the absolute value of that, and that equals 3. So 3 milliliters. A student measured the mass of an object to be 56 grams, but the actual is 53 grams. What is the absolute error? So our approximate is 56. The actual, or the exact, is 53. That gives us the absolute value of 3, or 3 grams. Percent error compares the absolute error to the exact value. When calculating the mass of an object in science, these are some examples, sorry. So, like when calculating the mass of an object in science, or measuring the distance an object has to travel. It can be solved using a percent error equation in which the values are plugged into the formula below. The percent error, it's written as a decimal, equals the approximate minus the exact divided by the exact. So our difference divided by our exact amount. Or the percent over 100, where 100 is the exact amount and the percent is the approximate minus the exact, or that absolute error that we have. During a school assembly, Mrs. Quinn takes attendance and counts 356 students. In actuality, there are 376. What was the absolute error? So we take the absolute value of our approximate minus the actual, or the exact, and that gives us 20 students different, okay? And the percent error is going to be that 20 divided by the exact, which was 376, and is going to equal our percent over 100. So that would be 100 times 20 divided by 376, which equals 5.3%. So 5.3%. Doesn't matter if it's over or under, we were off by 5.3%. Or Mrs. Quinn was, huh? She missed 20 students when she was counting. Okay. Switch pages. Read each of the situations below and answer the questions using your understanding of absolute and percent error. Several students are competing in a science club competition to build a car that will travel exactly 10 meters. The distance each student's car traveled is shown in the table below. What is the absolute error of each race car? So Emily's is 9.2 minus 10, or negative 0.8, or 0.8. Jerome's is 10.6 minus 10, or 0.6. We can even put zeros in front of them. Maricela is 9.8 minus 10, which equals the absolute value of negative 0.2, which equals 0.2. What is the percent error of each race car? So 0.8 divided by 10 equals what percent over 100? And 0.6 divided by 10 equals what percent of 100? And Maricela is 0.2 divided by 10 equals what percent of 100? So that gives us 8%, 6%, and 2%. Based on this information, what does a small percent error indicate? A small percent error indicates the car was closer to 10 meters and meets, or let's say better meets, qualification specifications. Okay, mark each of the following statements as true or false. Based on the data, Jerome has the smallest percent error. False. Maricela does. Emily's race car was the most accurate. False. Maricela's was, because she has the smallest percent error. She was only off by 2%, where Emily was off by 8%. Emily and Maricela had a negative percent error because their cars traveled less than the desired distance. False. Percent error is not negative. That's why we take the absolute value. We're just looking for how far away we are. Okay, Mr. Brown's class guessed the number of gumballs in the gumball machine in the cafeteria. After counting, it was determined that there were actually 408 gumballs. Okay, so this is the exact in the machine. Let's see, complete the table below to find the absolute error and percent error of the lowest and highest student guesses. So the lowest guess was 382. So the absolute error would be 382 minus 408. And that is 26. Let's see, hold on, sorry. I want to write this a little smaller. Say 382 minus 408, and the absolute value of that is 26. And this would be 456 minus 408. The absolute value of that is 48. All right, so the absolute, or the percent error would be 26 out of 408 equals what percent of 100? And 48 out of 408 equals what percent out of 100? This equals 6.4%, and this equals 11.8%. All right, good luck.